Find the vertical asymptotes. What is a vertical asymptote? Vertical asymptote is basically an invisible line that goes vertically down the coordinate system. For instance, let's start with the first example. The first example is called a regular vertical asymptote. Let's say that you're given this f of x equals to the first expression divided by the second expression, which is equivalent to a rational polynomials. Because rational polynomials basically means that you have an expression on the numerator divided by another expression on the denominator. That's what it means by rational polynomial. Okay, to find this vertical asymptotes for this given expression, there's like 3 steps to find the vertical asymptotes for a rational function. The first step is factoring, the second step is canceling, and the third step is solving for the x value. Now that we know the steps to find the vertical asymptote, let's go back to the regular problem. So the first step is to factor the numerator and the denominator according to the guidelines. So on the numerator 3x plus 5, you cannot factor any further. But for the denominator x squared minus 1, you can actually factor into this form and this form. Once you factor the numerator and the denominator, the next step according to the guidelines for the vertical asymptote, they tell us to cancel the like terms. Since the numerator cannot cancel with the denominator, so we just leave it alone. As for the last step of the guidelines for the vertical asymptote, they tell us to solve for the x value. So we set this expression equals to 0 and this expression is equal to 0 and solve for x. So to solve for x, you just plus 1 on the left hand side of the equation and plus 1 on the right hand side of the equation. So the x value for this equation will be 1. And as for this one, the x value will be -1. Once you have the x value, this value is actually the vertical asymptote for this particular given expression. So on the graph, it will look like this. So this is the y-axis and this is the x-axis. And this is the -1 for one of the vertical asymptotes, and this is the x equals to 1 for the other asymptotes. Now that we know the steps of how to find the vertical asymptotes, let's go on and do example number 3. Example number 3 involves a vertical asymptote that has a hole in it. So let me explain with an example. Let's say that you are given this expression right here. So according to the vertical asymptote guidelines to find the vertical asymptote, it says the first thing is to factor, the second thing is to cancel, and the third thing is to find the x value. So let's start with the first step. The first step says factoring. So on the numerator, when you factor this polynomial, it will become like this. As for the denominator, there's nothing you can factor, so it stays the same. Okay, once you factor the numerator and the denominator, the next thing is to cancel according to the vertical asymptote guidelines. So this x minus 1 and this x minus 1 on the denominator cancel with the numerator, so you're left with the x plus 7. Okay, so notice that on the denominator, you cannot have x equals to 1, because if you put 1 into this x value right here, the denominator will become 0. Whenever you have a number on a numerator and divided by a 0 on a denominator, it will be undefined. So when you graph this particular given expression, it will look like this. But notice that when you have an x equals to 1, notice that there's a hole on the graph right here, because the denominator right here cannot be equal to 1. Because if it's equal to 1, you will have an undefined rational polynomial. So that's why you put a 0 right here, because the denominator cannot be 1. Now let's go to the last example for a vertical asymptote that has no vertical asymptotes. So let me explain. So the last example will be called no vertical asymptotes. Like for instance, let's say that you're given this rational expression, and they want us to find the vertical asymptotes. So according to the guidelines, the first thing is to factor, the second thing is to cancel, and the third thing is to find the x value. So let's start with the first step. The first step, notice that the numerator cannot be factored and the denominator cannot be factored. So it's not factorable on the numerator and the denominator. Since it's not factorable, there's nothing to cancel according to step number 2. As for step number 3, it says solve for the x value. So we will use the denominator to solve for the x value. Every time you need to solve for the x value, always use the denominator to solve for the x value. So you take x squared plus 2 equals to 0. And when you solve it, you minus 2 on the left-hand side of the equation and minus 2 on the right-hand side of the equation. So you will have x squared equals to negative 2. And if you take a square root of it, the x value will become plus and minus radical negative 2. And to solve it, to get rid of the negative 2 inside the radical, you put an I outside to get rid of the negative expression. But notice that whenever you encounter this kind of problem where the denominator comes out to be a complex number, you have to recognize that you will not have a vertical asymptote, and the graph will look like this. Will look something like this and something like this. So there will be no vertical asymptote for this particular type of problem. So this is the 3 examples to finding the vertical asymptote of a rational polynomial. A rational function.